Okay, I'm going to go through the entire worksheet again, for those, especially for those who missed the lesson during ABP. Okay, so I'll just take some time to copy down the answers for the MCQ, and then I will go through each and every question. If you feel like you don't need explanation, you can just fast forward to the parts where you need explanation for. Okay, so for question 1, they ask what is the formula of manganese 4 oxide. Okay, please take note, what is the significance of this Roman numeral? This refers to the oxidation state, okay, or we short form OS, right? Okay, so this means that the manganese ion in manganese 4 oxide is Mn4 plus. Okay, and you know for oxide ion it is a O2 minus. Okay, so Mn4 plus and O2 minus. Okay, in this case you cannot do the crisscross method, because if you crisscross, okay, you will get Mn2O4, okay, which is incorrect because it's not the simplified ratio, and more importantly 4 and 2 actually have the same highest common factor of 2. Okay, so you cannot do that. So in this case what you need to do is you just balance out a 4 plus and a 2 minus. Okay, you realize that you need 2 times of 2 minus. Okay, you need 2 times of it, so answer is MnO2. Okay, so if you still have the habit of doing the crisscross method, you just need to double check whether or not the two charges, do they have the same HCF. Okay, there is not one. Okay, question 2, what change is oxidation? I think very straightforward, loss of electrons. Okay, what change is reduction? Decrease in OS. Okay, for OS we do not say loss in OS, we say decrease in OS. And we do not say gain in OS, we say increase in OS. Okay, what's the oxidation state of chromium in the oxide CrO3? We assign a value of x, okay, like algebra, assign x to the chromium because they're asking you to solve for the OS of chromium, which means that these are unknown. Okay, your oxidation state of each oxygen is a -2 based on the rule, so you have x plus 3 times -2 giving you 0 because there's no charge in this overall compound. So you expand it, you get x minus 6 equals 0. You bring over the 6, you get x equals plus 6. You must add the plus. Okay, in oxidation state, you need the plus or the minus. Okay, answer is C. Okay, question 5. Magnesium displaces lead ions from a solution of lead 2 sulfate. Okay, so what actually is the reaction that's happening? Okay, this is the full reaction which we will learn next year. Okay, next year in the metals reactivity series chapter. So this is magnesium plus lead 2 sulfate. Magnesium displaces the lead from lead 2 sulfate to form magnesium sulfate and lead, solid lead. Okay, so this is a reaction that take place. Okay, so how do you determine which of these 4 are true? Okay, if you read the options first, they talk about oxidizing either the magnesium atom or the lead ions, or the magnesium atom gaining electrons or the lead ions losing electrons. So if you look at the options, right, actually A and C, they mean the same thing, because when I lose electrons, I'm oxidized. So definitely these two cannot be the answer because they mean the same thing. Okay, unless there's 2 answers for the question, which is very unlikely. Okay, so let's consider between B and D. So you know that you have to something to do with the magnesium atoms. Okay, so in this case I can just focus on magnesium and ignore the lead. So how do I focus on magnesium? I just highlight the magnesium, okay, on the left hand side and the right hand side. So remember, on the right hand side, because it's a salt, it can ionize to form the ions, right? So you have MgSO4AQ. It can ionize to form Mg2 plus AQ plus SO4 minus SO42 minus AQ. Okay, so okay, what we are looking for is Mg as becoming Mg2 plus AQ. So what must happen to magnesium atom such that it can become a magnesium 2 plus ion? Okay, it needs to lose 2 electrons. So remember, lose 2, so minus 2. We do not, in chemistry, we do not write the, we do not want to write negative, so we bring this negative over and it becomes plus, like here. Okay, so because it loses 2 electrons, it is oxidized. Okay, it's not gaining, it's losing. Okay, therefore answer is B. Okay, this one will be shifted over. I'll just erase this. Okay, question 6. In which of the following changes is the first substance reduced? So please keep in mind when you have any questions that's underlined or any word that's underlined or bolded, please be extra careful. Okay, so in this case, first substance reduced, very simple for this question. You just need to calculate the individual oxidation states for every single element. So for A, you have K Cl, so K plus Cl minus, K ClO3, so K plus and ClO3 minus. So this is ClO3 minus. Okay, okay, if you want to go and calculate the charge of the Cl, I mean to really determine whether it's reduced, okay, you can go and calculate it. So it will be x plus 3 times minus 2 giving you minus 1. So x minus 6 equals minus 1. X equals positive 5. So in this case, it's a minus 1 to plus 5. So it's not it's not reduced, it's oxidized. Okay. For part C, HCl is H is plus 1, Cl is minus 1, Cl2 is 0. So chlorine changes OS, decreases OS from minus 1 in HCl to 0 in Cl2. So it is oxidized. Also wrong. Part D, Na2SO4 SO3. Na is a plus 1. SO3 is minus 2. Okay. Then in Na2SO4, Na is also plus 1. SO4 is also minus 2. Okay. If you want to check for the sulfur ion, right? The sulfur atom, what is the OS? So you have S, let it be X plus 3 times minus 2 gives you minus 2. So x minus 6 equals minus 2, x equals plus 4. Okay, in SO4, Na2SO4, okay, you let the OS of x be x, so you have x plus 4 times minus 2 equals minus 2 because the charge of SO4 is 2 minus. Okay, so x minus 8 equals minus 2, x equals plus 6. Okay, so same thing, it's a plus 4 to plus 6 is oxidized. Okay. Whereas the rest of the atoms, right, there's no oxidation or reduction because the OS stays the same. Okay, so answer has to be B. How do you double check there's B? Okay, you have Br2O. Okay, in this case, oxidation will take the minus 2 OS due to the rule. Okay, and then because oxidation is minus 2, oxygen is minus 2, each bromine has to be plus 1 because there's 2 bromine to give you plus 2. Okay. Then you know Br2 is 0 because it's an element, so bromine decreases in OS from plus 1 in Br2O to 0 in Br2, so it's reduced. Answer is B. Okay. For question 7, in which of the following reactions is the underlying substance oxidized by the other substance? Okay, so it's very straightforward. You just need to calculate the OS. Okay, so if you do the OS, okay, you check. Okay, for part, okay, let's start with B first. You have CaCO3. Okay, so if you know from here, Ca has to be plus 2 and CO3 will be 2 minus. Okay, so if you want to double check, actually CO3 2 minus, I mean if you go and calculate, you let the OS of C be x, so x plus 3 times minus 2 gives you minus 2, x minus 6 equals minus 2, x equals plus 4. Okay, and if you go and calculate the OS of carbon in CO2 is also plus 4, so there's actually no change in any of the OS of inside CaCO3. Okay, for part C, you have Cl2, which is 0, and then Cl minus is a minus 1. Okay, remember, you ignore the mole ratio. Mole ratio is only needed when you're comparing mole ratio. You never take into account mole ratio for any of other calculations. Okay, so from 0 to minus 1, okay, it is a reduction. So they want it to be oxidized. So the oxidation state must increase. So this is a decrease, wrong. Okay. Okay, last but not least, part D, you have H plus and H2O. So you notice that in H2O, the O will take a -2. Okay, so each H must take +1. So +1 to +1, no change in OS. So it's not oxidized nor is reduced. Answer must be A. Okay, double check why is it A. OS of iron is 0 because it's an element, and then it's oxidized to +2 in Fe2+. So increase in oxidation state is oxidized. Okay, so answer is A. Okay, question 8. Which of the following substances is a reducing agent? Okay, this one you have to refer to the textbook, I believe. Okay, carbon monoxide is a common reducing agent. There's a list of very common reducing agents and oxidizing agents in the textbook. In the slides, I only included like 3 of each. Okay. Question 9. Ozone gas is colorless and powerful oxidizing agent. What color change would you expect to see in aqueous potassium iodide? Okay, if ozone is bubbled through it. Okay, remember potassium iodide is a test for oxidizing agent. Why? Because itself is a reducing agent. So what is the change in OS? It's always a Ki, okay, to become I2 aqueous, which is the color change. Okay, so in Ki, the color is colorless, I2 is brown. So what is the change in the oxidation state of iodine? Is from -1 in Ki to 0 in I2. Okay, so okay, the color change is, since ozone is a powerful oxidizing agent and Ki itself is a Ra. Okay, because itself is oxidized, right? The OS of iodine increases from -1 in Ki to 0 in I2. Therefore, it's used to test for OA. Since ozone is a OA, this test will be positive. So the color change you observe will be colorless to brown, because Ki is used to test for OA and there will be a positive test. Okay. So if you use Ki to test for Ra instead, there will be no observable change. That means the Ki will just stay colorless. Okay, question 10. Okay, a drop of solution S turns acidified orange potassium dichromate 6 to green chromium 3 plus ion. So what is the change in the OS? Is +6. Okay, you go and calculate. Why? Because Cr2O7 is a 2 minus. So you have 2x, okay, which each chromium is x, plus 7 times -2, giving you -2. So you have 2x minus 14 equals -2. 2x equals to +12. Okay, x is +6. Okay, so you have +6 in K2Cr2O7 to +3 in Cr3+. Okay, and the color change is orange to green. Okay, and remember that since the change in OS is a decrease in OS from +6 in K2Cr2O7 to +3 in Cr3+, okay, chromium is actually being reduced, which means it is an oxidizing agent. Okay, so you need to remember that potassium acidified potassium dichromate 6 is actually an oxidizing agent, which means it's used to test for Ra. Okay, since there's a positive test change from orange to green color, answer must be reducing agent. Okay, so I remember some of you, there was a question asked why D cannot be an answer. Okay, D is not, it's not entirely wrong, but it's not specific enough, because D says a substance that can be oxidized. Okay, there are possibilities whereby a substance can be both oxidized and reduced at the same time. Okay, and that I will highlight that later on. It's called a disproportionation reaction. Okay, so you just pick the answer that's most suitable in this case, which is C. Okay, because since potassium dichromate 6 is used as a test for Ra, if there's a positive test, there must be a Ra present. So you just go for the answer that's the most direct. Okay, now for section A. Okay, before we even start this, okay, you will want to assign all the oxidation states to all the elements. Then it will be much easier to do. So you know that N will be a -3, H will be +1, Cl will be 0 because element, N is 0 because element, okay, H plus, H is +1 and Cl is -1, okay. So what is the substance reduced, which means that there must be a decrease in oxidation state, okay, which is chlorine is from 0 to -1. So decrease in oxidation state, okay, so Cl2 is reduced, okay. When they say substance, okay, you just take the whatever is in the formula in the balanced chemical equation, okay, ignoring the mole ratio. Okay, same thing, oxidize. You check nitrogen, oxidation state of nitrogen increases from -3 in NH3 to 0 in N2, therefore is oxidized. So NH3 is oxidized. Okay, opposite now, oxidizing agent, which means that the substance itself is reduced, so it has to be Cl2. Reducing agent is the substance that is oxidized, so it has to be NH3. Okay, remember we are focusing on the reactants because the reactants are the one that are either oxidized or reduced. You cannot pick the product as the answer. Okay, it will not make sense. The product can't be oxidized or reduced. Okay, part B, give a reason for your answer to A part 1, which is why chlorine is reduced. You just need to tell me oxidation state of Cl decreases from 0 in Cl2. Okay, remember for OS you must say the original oxidation state in whichever substance to the final oxidation state in the other substance, okay. So 0 in Cl2 to -1 in HCl. Okay, can you say that chlorine gains hydrogen? Possible, okay, because Cl2 gains H to become HCl, but because you look at the number of atoms, okay, 2 chlorine atoms become 1 chlorine atom. It's not very obvious, okay. So my recommendation is you still okay to use hydrogen, oxygen and electrons to check for redox, but you may want to double check with OS because OS is can be applied to all equations. So in this case, if let's say you say chlorine has gained H to become HCl and is reduced, you just double check with the OS whether chlorine is reduced. Since in this case it is reduced, if you say chlorine has gained hydrogen to form HCl and is reduced, will also be accepted. Okay? So for question 2, they give you the equation for the reaction between acidified potassium manganate 7 and aqueous iron 2 plus ions. Okay? So this is the entire reaction. Okay, you may want to, when you're given such equations, you may want to write down all the OS first. Okay, so I identify that Fe is Fe2 plus is +2 OS, and then Fe3 plus is +3. So the change is +2 to +3 for iron. Okay, for manganese in MnO4 minus, okay, if you go and solve, okay, Mn is a +7 because it's a x plus 4 times -2 gives you -1, x minus 8 is -1, x equals +7. Okay, so Mn is +7 to +2 in Mn2 plus, so it is reduced. Okay, so let's write this one is oxidized, this is reduced. Okay, and then let's check for hydrogen. It's a +1 here to also a +1 in water. So there's no change in OS, it's neither reduced nor oxidized. Okay, oxygen is a -2 in MnO4 minus to -2 in H2O as well. So no change for H and O. So there's only one oxidizing agent and one reducing agent. Okay, so since Fe is oxidized is the reducing agent, and since Mn is reduced is the oxidizing agent. Okay, so they ask you which is the reducing agent, is Fe2 plus. Okay, remember reducing agent always refers to the reactant. Okay, so you say Fe2 plus. How do you explain? You can say oxidation state of Fe increases from +2 in Fe2 plus to +3 in Fe3 plus. Okay, therefore it's oxidized. Okay, for part B, briefly describe how aqueous potassium manganate can be used to test for reducing agent. Okay, this one is just the test for Ra using KMnO4. So first you have to acidify it with sulfuric acid. Why need to acidify? If you do not acidify, there will not be any H plus ions. Okay, so this is from acid. There is no H plus ions to allow this reaction to take place because you need the electrons. okay, there needs to be electron transfer. Without the sulfuric acid to provide H plus, okay, this reaction cannot happen, okay. So after you have acidified it, you add a few drops of acidified KMnO4 to the unknown solution, okay. If the mixture turns colorless, okay, the unknown solution contains a reducing agent. Why? Because originally KMnO4 minus is purple. Okay, so when it's reduced to Mn2 plus, it will turn colorless. So if, okay, Ra is present, so in this case the Ra in this question is Fe2 plus. If Ra is present, this purple color will turn colorless. Okay, so when you see this turning colorless, the unknown solution will contain a reducing agent. Okay, so obviously if there's no color change, okay, then it does not contain a reducing agent. Okay, next, cuprite Cu2O and paramalachonite CuO are two natural ores of copper. What is the OS of copper in each ore? Okay, so remember oxygen will take -2. So copper is +1 in Cu2O and +2 in CuO. Okay, I mean it's also reflected by the name. So if I want to name this, it will be copper 1 oxide. So 1 refers to the OS. Okay, and this one will be copper 2 oxide. Okay, the 2 refers to a +2 OS. Okay, so copper can be extracted from cuprite by heating with carbon. Construct an equation for the reaction. Okay, so you start with Cu2O plus C. Okay, and you extract copper, which means you need to form copper. Okay, the other product will be CO2. Okay, like I mentioned in class, if you wrote the other product as carbon monoxide instead of carbon dioxide, the reaction is actually wrong because there's no transfer of electrons. Okay, so for the most part, unless specified, just assume CO2 as the other product in extraction. Okay, so in this case, you just balance Cu2O plus C gives you Cu plus CO2. You balance it with a 2 and a 4. Okay, next, explain in terms of electrons why copper is reduced. So in order to be reduced in terms of electrons, you need to gain electrons. Okay, so you need to identify what is a change in whether or not copper has gained or lost electrons. So in Cu2O, okay, copper is actually +1. So it's a Cu plus, right? If I split it, Cu plus and O2 minus. Okay, and then in Cu, it is an element. So Cu plus to become Cu, what must happen? Okay, Cu plus to Cu, you must gain an electron. Okay, because it has a positive charge, you need to neutralize the positive charge by adding an electron. So in this case, you just say Cu plus gains electrons to form Cu. There's no need to specify the number of electrons gained. As long as you say gain or lost electrons, it is fine. Okay. Okay, now for part C, a sample of one of the ores was analyzed and found to contain 3.2 grams of copper and 0.4 grams of oxygen. They give you the AR of oxygen and copper. Okay, calculate empirical formula. Remember the table method. You need mass in grams, the relative atomic mass, the moles in mole, and mole ratio. Okay, so you have copper and oxygen. Okay, the mass of copper is 3.20, mass of oxygen is 0.40 grams. Okay, the relative atomic mass take from periodic table. Copper is 64, oxygen is 16. Okay, moles. Okay, you calculate, you take mass over molar mass. Molar mass is just your AR with units G per mole. So you take 3.20 divided by 64, you get 0.05 mole. Likewise for oxygen, you take 0.40 grams divided by 16 grams per mole to give 0.025 mole. Okay, now to find mole ratio, you simply take divide the number of moles by the smallest number. So you divide both of them by 0.025. 0.05 divided by 0.025, you get 2, and 0.025 divided by itself is 1. So the empirical formula is 2:1, 2 carbon is to 1 oxygen, so it's Cu2O. Okay, and deduce the name of this ore. Some of you will have written cuprite. Okay, but since they say deduce, they are probably asking you for the actual name. Okay, don't worry, in O level it will be very specific whether or not they want you to identify the what we call the trade name of the ore, okay, or the chemical name. Okay, so in this case it has to be copper 1 oxide. Okay, now for question 4. Okay, now you have acidified potassium manganate 7, so same as earlier. Okay, but this reaction is with hydrogen peroxide. Okay, and the equation is given 400 cm³ of aqueous hydrogen peroxide. Okay, this is your H2O2. Remember, is given in the question, so please read. If you don't know the formula, most likely it might be provided in the question. Okay, 400 cm³ of potassium hydroxide, of hydrogen peroxide required 0.05 mole of MnO4 minus. So you can write 0.05 mole of MnO4 minus 400 cm³ of hydrogen peroxide. Okay, what is the OS of manganese atom? So your Mn, okay, if you go and calculate, remember it's always a +7 in MnO4 minus, okay, and from Mn2 plus it is a +2. Just take the charge. Okay, and remember the sign goes before the number for oxidation state. Okay, so what two changes you will expect to observe when acidified potassium manganese added to aqueous hydrogen peroxide? Okay, how do you tell whether there is I mean, in this case they ask you to state two changes, but if let's say they ask you if there will be changes, how can you tell? Remember, potassium, your acidified potassium manganate 7 is a OA, right? Then it itself is reduced because Mn is +7 to +2. Okay, so it's a OA. If you can see that the MnO4, if you can see that the manganese has been reduced because the OS has decreased, okay, from +7 to +2, it means the other substance added must be a Ra, because it has reduced your potassium manganate 7. Okay, so because there is a positive test, okay, and remember your potassium manganate 7 is used to test for Ra. So the positive Ra test is color of aqueous solution changes from purple to colorless, okay, as well as effervescence form. Why? Because there is oxygen gas produced. Okay, is produced in a liquid mixture. Can you see liquid with aqueous? Okay, it's produced in an aqueous solution, so there will be bubbling. Okay, now they ask, have MnO4 minus been reduced or oxidized? Explain in terms of oxidation states. Remember, the question will specify, you have to answer according to the question. It is reduced, you just tell me OS decreases from +7 in MnO4 minus to +2 in Mn2 plus. Okay, next, calculate the moles of H2O2 that reacted with MnO4 minus. Okay, remember the mole ratio is 5:2 for hydrogen peroxide to potassium manganate 7. So I swap it around 2:5 because I wrote in the other way, because we are given moles of potassium manganate 7. Okay, so usually you write the unknown on the known on the right hand side, the left hand side. Then you solve for the unknown on the right. So 2:5, 0.05 mole. Well, you just divide this 0.05 by 2 times 5, you get 0.125. Okay, compare by mole ratio only. Okay, next, calculate concentration of aqueous hydrogen peroxide in mole per dm³. Make sure you highlight the concentration units, because sometimes they might ask you for grams per dm³. Okay, so you just take the moles of hydrogen peroxide divided by the volume. Volume, remember, they give you in cm³. Convert to dm³, because the answer wants in mole per dm³. You get 0.3125. You round off to 3SF, 0.313 mole per dm³. Okay, next they ask, a compound with formula MnSO4 is one of the products of the reaction. Name this compound. So you have to figure out the charge first, okay, of manganese, okay, or aka the OS. Okay, so you know SO4 is 2 minus, then you split it, it must be Mn2 plus, so it's manganese 2 sulfate. Okay, for section B, okay, question 1. They say tin cans are used as containers for food. consists of a steel alloy coated with a layer of tin metal. The tin used to make tin cans is extracted from the calcitride SnO2 by reducing it with carbon, producing molten tin and carbon monoxide gas. Make sure when you see all this, right, the words like or, by carbon, molten gas, please highlight because they are telling you the states. Okay, question part 1, construct balanced chemical equation with state symbols. So you know that the calcitride SnO2 reacts with carbon, okay, to form tin, which is Sn, and carbon monoxide gas, okay, CO. Then now, before you even put in the state symbols, you must balance first. Remember, if your equation is not balanced, there is no marks awarded even if you get the state symbols right. So focus on the balancing and writing correct chemical formula. Okay, so I have okay, let's start from scratch how to balance this. Okay, because I noticed that I have lacking oxygen on the right hand side. Okay, I have 2 oxygen on the left, I only have 1 on the right. I need to double CO. Okay, and now that I double CO, I realize that I have shortage of 1 carbon on the left hand side. I need to double the carbon. So this is how you balance. You check, okay, Sn, 1 Sn on both sides, okay, 2 Cs on both sides, 2 Os on both sides. Okay, explain why carbon is a reducing agent. Okay, you can calculate the oxidation state of carbon. Okay, remember carbon as an element, it is 0. Okay, in CO it is a +2 because oxygen will be -2, carbon has to be +2. Okay, so oxidation state of carbon decreases from 0 in C to +2 in CO. So it is a reducing agent because it itself is oxidized. Okay, part B, tin used in making tin cans can be recycled by heating with chlorine to produce tin 4 chloride. The tin is then recovered by heating the tin 4 chloride strongly to decompose into tin and chlorine. Give the formula of tin 4 chloride. So tin 4, remember, the Roman numeral correspond to the OS. So tin 4 is SN4 plus. You know chloride is Cl minus. Balance out is SnCl4. Okay. Construct the equation for the thermal decomposition. Okay, what is thermal decomposition? It just means decomposition by heat. You start with 1 product, you form 2 or more. Okay, so you decompose tin 4 chloride. Okay, and they already tell you you decompose it into tin and chlorine. Okay, so you start with SnCl4, you form Sn plus Cl2. Remember to balance out Cl4, you need to times 2 to Cl2. Okay, so next they ask for, in terms of oxidation state, why this decomposition can be described as a redox. So to describe something as a redox, you need to show that both oxidation and reduction are taking place at the same time. So you need oxidation plus reduction. How do we show oxidation? You just calculate the OS of every element involved. So Sn is +4 because it's tin 4, Cl is -1. Okay, oxidation state of tin in the metal itself is 0 because it's an element. Okay, as well as 0 in Cl2 because it's also an element. Okay, so you notice that it's +4 to 0 for tin, -1 to 0 for chlorine. Okay, so since oxidation state of tin decreases from +4 in SnCl4 to 0 in Sn, it is reduced because decrease in OS. Okay, likewise, for the opposite case, okay, the OS of Cl increases from -1 in SnCl4 to 0 in Cl2, increase in oxidation state, so it's oxidized. Since both oxidation and reduction has occurred, this is a redox reaction. Okay, last two questions. Okay, ammonium chlorate 7, okay, NH4ClO4 is used as a solid fuel in rockets. On strong heating, it decomposes into nitrogen, chlorine, oxygen, and water. Okay, construct an equation for the thermal decomposition of ammonium 4 chlorate. Remember, what is the 7 here referring to? It refers to the chlorine atom. Okay, the OS of the chlorine atom. Okay, how do we figure that out? Okay, you can start with the whole formula, NH4ClO4. Okay, because we already know that ammonia must be NH4+. Okay, which means that ClO4 must be a minus because it must balance out the charge. Okay, then you let the OS of chlorine be x, so you have x plus 4 times minus 2 gives you minus 1, x minus 8 equals minus 1, x equals plus 7. Okay, so this is just a simple way to double check what the question is referring to. Okay, in this case, the 7 is not referring to the charge of the chlorate ion, but rather the chlorine atom. Okay, so you can always double check by calculating. Okay, so you start with ammonium chlorate 7, form nitrogen, chlorine, oxygen, and water. Remember, nitrogen, chlorine, oxygen, they exist as diatomic molecules. So you must write N2Cl2 and O2. If not, you cannot get the answer. Okay, so now how do you balance it? Okay, you notice that let's start from scratch. Okay, so if you compare the left hand side and the right hand side, you notice that, oh, there's a shortage of nitrogen on the left hand side. Okay, there's 2 N on the right, but there's only 1 N on the left, so I go and times 2 first. Okay, now that when you times 2 to the left, you realize that there's 2 chlorine, so chlorine is already balanced. Okay, so next you check for water. You check for hydrogen first, because oxygen is repeated in 2 things. You check for hydrogen first. So H2 on the right hand side, but you have 2 times H4 on the left. So you need 8 hydrogen on both sides, so you need 4 H2O. Because I put 4 in front of H2O, there's 4 oxygen plus 2 oxygen, there's 6 oxygen on the right. Okay, but there is 2 times 4, 8 oxygen on the left. So I need to add another 2 oxygen, so I need to times 2 to O2. Okay, now you can go and double check. Okay, it's balanced. Okay, next, explain why chlorine is reduced in terms of oxidation state. Okay, remember oxidation state of chlorine changes from +7 in NH4ClO4 to 0 in Cl2. Therefore, it is reduced because the oxidation state decreases. Okay, +7 in NH4ClO4 to 0 in Cl2. Okay, last question. Chlorine reacts with water in a disproportionate. Okay, so this wasn't covered in the slides. Okay, in the lesson. What does disproportionation mean? Okay, same element is both reduced and oxidized. Okay, so we will see this in this disproportionation in this reaction. Okay, oh, they did explain. Okay, oxidation state of the same element both increases and decreases. Okay, so using ideas about the oxidation state, explain why the above reaction is a disproportionation reaction. Okay, you just go and calculate the OS of every single element first. Cl is 0 because it's an element. Okay, in H2O, H is +1, O is -2. HCl, H is +1, Cl is -1. In HClO, H is +1, O is -2. How to find chlorine? Okay, so you HClO. Okay, you have +1 plus X. You let chlorine be X. Okay, plus -2 equals 0. So you have X minus 1 equals 0. X is +1. Okay. How would you know that chlorine doesn't take -1? Because it's not possible, right? Because you already noticed that the oxidation states of of hydrogen and oxygen has stayed the same, +1 and -2 respectively. So the only possibility for chlorine to be both reduced and oxidized, okay, one of the chlorine atoms must have a +1 oxidation, a positive oxidation state. Because you have a negative oxidation state here, this one has to be positive. So that this chlorine here, starting from 0 OS, can be oxidized to a +1, to a positive in HClO, and also reduced to a negative OS in HCl. Okay, so you can just say, now that we have calculated all the OS, you say oxidation state of chlorine increases from 0 in Cl2 to +1 in HClO. Okay, so it's, in this case, is oxidized, right? Okay, can we add in and it's oxidized? Is oxidized. Okay, then we can say it oxidation state of chlorine also decreases. okay, decreases from 0 in Cl2 to -1 in HCl and is reduced. Okay, then since Cl is both oxidized and reduced, the reaction is a disproportionation reaction. Okay, so if you have any more, if you still have questions about this worksheet, okay, you can just text me your question.